So to solve a system of equations by graphing. Now, systems of equations can have two or more equations in them. We're only going to be looking at systems with two equations. So they're going to look something like this. You're going to get two linear equations. You're going to graph them on the same graph and find the point of intersection. Once you find the point of intersection, you identify it by writing it as an ordered pair, and then you check your answer in both equations. If you know how to graph your lines well, this will be a fairly quick sort of process to do. If you don't, I can't fully explain how to find all of the information for each line and graph them because it makes this video far too long and then YouTube will not accept it. So if you're still struggling with how to graph lines in the first place, please go back and watch the videos and take notes carefully over Learning Targets 3.3 and 3.4 because this will be a very quick video, relatively speaking. Reminders on every graph: use a straight edge, which may or may not be a ruler. Put arrows at the ends of all lines, including the x and y axes, and don't forget your scale. You are able to go by ones on all of these graphs, so you're required to go by ones on all of these graphs. Now a quick look at my thought process for how I graphed these lines. And again, pause this video at any point if you want to look more carefully at any of these screens. I've thought about where the y-intercept and the slope were on this line, and found the x and y-intercepts when it was in standard form, and at least visualized, if not actually sketched, a very quick sketch of what the graph would be. This allows me to know that I need to get all the way over here to positive 6 on my x-axis, so I need to leave room to do that. I also have to get up to both positive 7 and down to negative 3 on the y-axis. Now in order to do that, since there are only 10 squares on the grid, I have exactly one place where my x-axis will go that makes this work. So then I actually graphed these two lines. Again, my x-axis, in order to get down to negative 3 and up to positive 7, this is the only place my x-axis could go. My y-axis could go a little bit, one more square to the right or a couple other squares to the left, but I do need to make sure that I can get over here to positive 6. I need to make sure also that the point of intersection is on the graph. So for the first line, it crosses the y-axis at positive 7. A rise over run of negative 2 over 1 means I go down 2 to the right 1. And notice with the red dots that I carried that pattern across the graph so that I could draw my line, my nice straight line, all the way through the graph and then put arrows at the ends. The second line, my y-intercept was negative 3. My x-intercept was positive 6. So then, after I got those graphed, I drew my line through those 2 points, again, extending the line through the graph, and drew arrows at the ends. My final answer is the actual ordered pair of this point of intersection, which is the point 4, negative 1. Now, make sure that you write the parentheses and you circle that final answer. To check this, you take each individual equation, so like the y equals negative 2x plus 7. You don't have to write the check out on these, but this is what it would look like if you did. Where I see y, I'm going to substitute the negative 1 from my point, and then in the equation where I see x, I'm going to substitute the 4. The same work you did in Learning Target 4.1, simplify this side, check to make sure that both sides are equal. That means this point is on the first line. And then do the same thing for the second line. Should be true for both of them, or something's wrong with your answer. The second graph, again, pause this at this point if you need to look at this screen a little bit longer. I worked myself through that the y-intercept here was 0 and the slope was 1/2. The y-intercept of the second line is 9 and the slope is negative 1. A quick sketch of the graph showed me I need to get up to positive 9. Nothing very interesting is happening on the left side of the equation, but I do need to get over here to the right a ways to find that point of intersection. So I set my graph up pretty close to the left edge from my y-axis to make sure I could get over to the point of intersection. I had to get to positive 9, so my x-axis can either go where it is here, or it could have gone down one grid line. The first one crossed the y-axis at 0 and a slope of positive 1 over 2, and I did that 1 over 2 across the graph to draw my line. The second one, y-intercept of positive 9, a slope of negative 1 over 1, Again, stepped that across the graph. Then I had to take my x scale out to make sure it covered the point that I just graphed. And again, I say you're probably going to have to pause this video several times to catch up with the notes themselves. Once you get caught up with the notes themselves, then resume the video. My point of intersection is the point 6, 3. If I were to write my check down, at least that first line of the check, again, I take the original equation, y equals 1/2 x, substitute 6 for the x, 3 for the y, then I would simplify this, probably plug it into my calculator, make sure that both sides really are equal. There are two special cases. One is where the slope of the line ends up being the same. The slope is positive 3 in both of these cases. The only thing that's different about these two lines is the y-intercept. So if they have a different starting place on the y-axis, but the slope is the same, they end up being parallel. Now, when I get ready to actually graph that, -4 is the first y-intercept. A slope of 3 means rise 3, run 1. Again, carrying that across the graph. The second one, a slope of +2, rise 3, run 1, or go down 3 and go to the left 1. Once I draw my lines in, put the arrows at the ends, I realize again these are never going to intersect, so my answer is, the answer on these, your solution is the point of intersection of your two lines. These lines never intersect, so there is no solution. And I also on this one want you to give an explanation of why there is no solution, parallel lines. Now on D, please change the second equation to y equals 3/2 x minus 3. There was a typo on this that I forgot to fix. So, when I do a sketch, I found the x and y intercepts of the first line, the y-intercept and the slope of the second line, and when I sketched each of those, I realized that they're going to end up being the same line. So I transferred that information to my final graph because I knew the x-intercept was 2 from the first line and the y-intercept was -3. The second line, the y-intercept is -3, and when I rise 3 and run 2 in the positive direction, I end up at the point 2, 0 as well. So, again, the solutions are the point of intersection of the line. Well, these two lines intersect at every point along the line. So every line has an infinite number of points, which means there are infinitely many solutions on this problem. And again, just like the previous one, why is that the case? Because they're the same line. If you need to rewind this video and go back and pause at any of the screens, rewind any of the explanation, please do so. Thank you.